Anyway, all right. Okay, so what we're going to do next. Last time, what I was doing, I did the inverted. I did the pendulum like this, and I was asking the question: are you able to use Newton's second law of rotation and get both the equations of motion and the reaction force? And I did it a couple different ways. One way I did it with this exploded diagram, and I don't think I got much. And then I did it with this diagram. No, I did it. I don't remember how I did it. I did it this way. Yeah, I must have done it with the 3Ks with the C, and then I did it with the W, and that was one. And I did get the equation of motion, and then I did it. Then I think I did it this way, and I moved the W over to this point. Anyway, and then I said I wasn't able to get the reaction force. And then Anketer almost suggested, what if you take the unforced particle, move it over to this point, but make the exploded diagram like this. Anyway, so he was suggesting put the W over here, but make this the exploded diagram. Yeah, I'm confusing you guys. Anyway, I hadn't worked that case, and Ankit worked it out, so Ankit's going to present it. Yeah, you need to calm down. Present it. Anyway, just let me clarify. So this will be the body. So this will be the body. So when we explode it, we're going to keep these two pieces together, and we're going to separate it from the ceiling. But we're going to pick this to be the W, not the pivot point. Not the pivot point. All right. Yeah, he's going to be a future professor someday. And if it takes you a lot of years to get your PhD and you need to repeat this course, you might get them as, I'm just kidding. Oh, wait a minute. All right. Oh, you're going to do it with a computer. I didn't think of that. You can teach with a computer. It's amazing what they think of.
I'll get all the notations.
Oh, yeah, I'll be like your assistant. I'll erase the board. Wait a minute. All right. Oh, that's a scarf. All right. All right. All right.
Yeah, we can actually move this.
You can write at this board, or would you like a new board?
No, I can start with that.
All right. All right. Yeah, we'll see how he does.
Yeah, okay.
If you do too good of a job, they'll wish that you finished the course. But anyway, all right.
I'm going to get paid equally.
No way.
Yeah, I'll do a crappy job. Okay, so you have this simple pendulum setup. It's pivoted at this point. So we call this point C, and that's W is the first part because it's stuck in this wall or ground or whatever you want to call it. P is the pivot point. C is the center of mass, so the link is massless. So we'll start with frames. That's FA, I'll call that IA, that BJA. Let's call this angle theta, and I will have a frame like this, IB, JB, where JB is pointing along the length of the pendulum or the massless link. Let's call this distance alpha, this distance L. What else? I need gravity. Gravity is in this direction. Okay, what else? Yeah, that's pretty much it. So the frames are related by this Euler rotation about the third axis, and the angle is going to be theta. So this implies that omega VA is just going to be theta dot Ka or Kb. Okay. Also, I have FB transpose equals O3 theta FA transpose. So you get like IB equals cosine theta IA plus sine theta JA. I'm writing these equations because they would be used and this would be sine theta RA plus cosine theta JA. Thanks. What else? So we know a couple more things. What is RCP? So that's, so you're standing at P looking at C. That's going, yes.
Is it minus theta?
No, good question. So in this picture, to get to this picture, the value of theta is negative. It is not minus theta. Theta is a negative number. So if theta was a positive number, then the pendulum would be looking like this. Right? So in this picture, it just happens to have a negative value. But theta is just a variable. It's not a negative theta.
Show this as a direct angle.
Yeah. Actually, so increasing, I need the increasing direction, right? So that would be actually this. But, so in that case, I would want to start it at this point. That's why I don't like directed angles. I mean, they are confusing. So okay, let me redraw.
Can you believe he said that?
Let me redraw this. Let me correct that.
On
Okay,
Oh.
scratch the last statement. So this is the directed angle. That's point C, and that's B.
You almost killed me. Oh man.
Okay, so in this picture, theta happens to be a positive number.
He thinks he's gonna get a PhD. All right, I'm
Oh,
just.
you're pulling that card. Okay. I like directed angles. Okay, so that's the direction of increasing theta, and hence the arrow. And this length was L. So RCP is you're going in minus JB direction, and you need to travel L distance, so that's minus LJB. And RPW is you're going in negative IA direction, alpha, so that's this. Okay, so we have the complete set of information that is given in the problem, and all you need to do is apply the Newton's second law of rotation. So Newton's second law of rotation about the W is actually HBWA, A dot, equals MBW, where B is the body, script B. Okay, just assume that that's script B. So HBWA, by definition, is, what is that? That's the RCW, that's, and C is the center of mass, times the M, no, that's a cross product, and M times VCWA. So that's just by definition. So what is RCW? RCW is RCP plus RBW crossed with M. VCW is going to be RCW, RCP A dot plus RBW A dot. Okay? So RBW A dot, you see, is going to be a constant value. So when I take the A dot of that, it just goes to 0. That's a 0. And what are these things? So RCP is minus LJB minus alpha IA crossed with, so that's going to be minus LJB A dot. Okay? And this is equal to, what is JB A dot equals to? So you use single transpose theorem, you get JB B dot, which is 0, plus omega BA cross JB. And what is that? Omega BA now is theta dot Ka or Kb. So you get, this is equal to theta dot Kb cross JB is minus IB. So you get minus IB. So you have to now cross that vector with these guys. So you get, so you have a bunch of minuses, they cancel out. So the first term is going to be L, M, and theta dot. So M, L, theta dot. JB cross IB, that is going to be minus KB. KB is also equal to K, so let's just write KA. And the next guy is going to be M alpha theta dot. That's going to be IA cross IB. So I want to write IB in the IA form because I want everything in the A frame because that's where I'm going to take the A dot. So this is IA cross IB. So you can see IB there. So you take the IA cross of that, you get IA cross IA, 0, and then IA cross JA, so that gives you KA. So that you get a sine theta here. So this would become minus ML theta dot plus M alpha theta dot sine theta KA. Yeah, let me make sure that that's what I got. No, I got negative of that. So I missed a negative somewhere.
Yeah, I think you had too many minus signs. This, and this cancel. But then when you did this, you picked up an extra minus.
Oh,
And then when you did another cross, you got yet another minus.
So I have a minus of this whole thing.
He does a lot in his head. I wouldn't
So-
do that much in my head.
So this is M alpha theta dot sine theta. Yay. Okay. So I think I would have wasted a lot of time trying to get that out. Okay, so now you have to take the A dot of this expression. And that's easy because you only need to take the dot of the scalar part because we are already in the A frame. So this A dot is just going to be M L theta double dot. So that's the first term, and the second term is M alpha theta double dot sine theta plus, so theta dot cosine theta theta dot. So that's theta dot squared cosine theta. And the whole thing is along K. So that's the first half of the equation, yes.
So you're missing an L in that? It should be L squared and L alpha.
Ooh, yeah, I also missed this L. Yeah, thank you for that. So let's say minus L. Minus L squared and L. And an L here. So let me make it full. Hopefully this is correct. ML squared theta dot. And minus M alpha theta double dot sine theta plus theta dot squared cosine theta. Okay, so that's the first half of the equation. The other half is the MVWA. So MVWA, no, there's no way. So just MVW is by definition, so YIW cross FYI, where YI are all the points at which there are forces. So I may be 1 to 2 in this case. So there are 2 forces. What are those forces? So if you look at this picture, there's the gravity force, mg, and there's a reaction force, F. I don't know the direction, I'm just going to choose this direction. So these are the only 2 points at which there are forces. Actually, it's at this point, I maybe should draw it like this. So you don't need to assume the direction, just it's along the length of the massless link. Okay, so that's going to give you RPW cross FR plus RCW cross MG. Okay, so RPW is what? It's minus alpha IA cross, so we just assume that this is FRIB, not IB, JB. If it's plus, it would come out in the equations. And then the second part is going to be minus LJB minus alpha IA cross MG, and G happens to be in the negative JA direction. So I'll say G minus JA. this is minus alpha FR IA cross JB. Now JB happens to be that guy, so that's minus sine theta IA. I'll just repeat that equation, plus cosine theta JA. And then I have, so yeah, again, these minuses cancel. Plus I have an NG out. LJB cross JA. So I want to write JB in terms of the A vectors. So that's going to be minus sine theta IA plus cosine theta JA. And plus, so this whole thing multiplies L, and then plus alpha IA cross JA. I think I got everything. So I have IA and JB, and I have JB, IA, and JA. Okay, so let's do the cross multiplication. So that's minus alpha FR. IA cross IA is 0, and IA cross JA is KA. So that's cosine theta KA. Then you have that MG L, now JA multiplying the whole thing. So that gives you, what does that give you?
Just
IA cross J. Yeah, this would go 0 and this would go 0. So IA cross J gives you KA. So that's, and you pick up a minus sign. So there's a minus sine theta KA. And then you have plus MG alpha, this alpha, IA cross JA, that gives you a KA. Okay, so this gives you minus alpha FR cosine theta minus MG L sine theta plus MG alpha K. Okay, so now you just equate this guy with this guy, and that should give you something. So let's see what that is. Yeah, I shouldn't have used the bottom.
I want to just write it there.
Okay.
It's already there.
Yeah, okay. Okay, so if you write these two equations, actually I can just write this
Yep, right.
there. So that's going to be ML squared theta double dot minus M alpha L theta double dot sine theta
Yep.
plus theta dot squared cosine theta. And this is also along K. So the scalars have to match. So you get this equals this, but then you have just one equation. Now the equation of motion and the equation for the reaction force are just motion into one equation. So you can collect the alpha terms and the rest of the terms. So what are the alpha terms? So if I'll keep everything without alpha on the left side and everything with alpha on the right side. So on the left side I get minus ML squared theta double dot, and I have a minus MGL sine theta, MGL sine theta. And everything else is alpha. Okay, so alpha, I have minus ML theta double dot sine theta plus theta dot cosine theta, so there's a square. And then I have this guy coming on the right side, so that's going to be FR cosine theta. Okay, so now this equation is true for all values of alpha, right? So if you choose alpha to be 1 or 2 or 4, yeah.
You also have an MG alpha?
Yes, 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 yes. So that's a minus NG. Because when I move it to the left, I get a minus. So if that equation has to be true for all alpha, I mean, it cannot be true for all alpha, right? I can choose another alpha at 3 units or 5 units or 8 units, and it cannot be equal to all of those factors. This is not equal to twice of this, and this is not equal to 5 times this. So what is the only possibility here? That this term has to be 0, right? So you get this equal to 0, and you get this equal to 0. Right? So the first term equals 0 gives you ml squared theta double dot plus mg L sine theta equals 0. That's the equation of motion. Right? It doesn't have any external forces. And the second term, which is this, gives you the reaction force, which you can actually simplify a little bit further by substituting this theta double dot here. So let's try to do that. So that's going to be Fr cosine theta minus mg and minus ml. And let me write, instead of theta double dot, let me write minus mgl sine theta over m L square. So that's theta double dot times sine theta. And this this whole thing is 0, right? So I cancel m, I cancel 1L from here. Okay, what else can I cancel? Actually, I cannot cancel anything else. So this is Fr cosine theta. I'll take this term out, minus ml theta dot square cosine theta. And I'm left with this minus mg plus mg. This L cancels out this L sine square theta. And that's minus 1 plus sine square theta. That's minus cosine square theta. Right? So I can remove this. I can call this cosine square theta. And then I can cancel the cosine theta. Oh, this whole thing is 0. This cosine goes away, and this cosine goes away. And that's the reaction force.
Awesome.
Right? That's it. So you get both equations from the HPW A hour equals MVW into LR about W. Right?
Any questions? Any questions?
Yes.
For Ankit?
So alpha has to be,
Alpha could be anything.
oh, alpha could be anything.
So let's say alpha is 1. Okay, so this guy is equal to 1 times this. But then you can say alpha is equal to 5. And the same thing is equal to 5 times this. So what is the only possibility in that case? This has to be 0. Right? 5 times 0 is 1 times 0, but 5 times 1 is not 1 times 1. That's why both of these terms are 0.
Yeah, other questions? Actually, I had a slightly different interpretation of, yeah, great job, of what Ankit actually just did. The way I interpreted, he actually did the problem twice. When you look at the alpha equation, where's the alpha equation? All you need to do is you take this alpha and you do it twice. You set the alpha equal to 0 and you set the alpha equal to 1. You just pick those two values, and what that means is what he did in effect was he took the W and he put it at that location, and then he put it at that location. So he basically did it twice. And when you take the alpha equal to 0, you just get the equation of motion. And then when you take the alpha equal to 1, you get an equation that's a mixture of the equation of motion and the reaction force. But since you already know the equation of motion, you can take it out and you get the reaction force. Anyway, he didn't agree with that interpretation. You still don't agree with it, right? Anyway, but what this basically shows is you're able to use Newton's second law of rotation on this example, and yes, you can back out both the equation of motion and the reaction force, but you need to do it in a slightly more clever way. And the trick to doing it was to make this the body and to take the W to be offset from the pivot point. Now, who would ever think of that? Ankit thought of it, but you know, I'm just showing you. You need to be a little bit clever how you do the exploded diagram. Anyway, it's interesting. It took them 3 complete boards to do that. Anyway, great job. Thanks. Yeah. Any other questions?